Chapter 12, Liquids, Solids, and Intermolecular Forces. We talked about gases in a previous chapter. Now we're going to talk about liquids and solids. Have you ever wondered why things taste the way they do, or how you taste at all? You ever stop and think about that? It has to do with the interaction between molecules in the food and molecules on your tongue. There are specialized receptors on your tongue that interact with molecules in the food. And those send signals to your brain, and you recognize that as a sweet taste or a salty taste or whatever. Those interactions are caused by intermolecular forces. These are forces of attraction that exist between molecules. Inter means between. Intermolecular forces are responsible for many physiological processes. There are less specific intermolecular forces that occur between all molecules and atoms. And in fact, these are responsible for the very existence of solids and liquids. Without intermolecular forces, everything would be a gas. So the physical state of a sample depends on the strength of the intermolecular forces relative to the amount of thermal energy that it has. All atoms are in constant random motion, even molecules in solids. They're vibrating. As you increase the temperature of a substance, its average kinetic energy increases and the particles move more. Eventually, they'll get to a point where they can break away from the forces that are holding them together. And that's when something melts. So if the intermolecular forces are very strong, I kind of think of intermolecular forces as being like Velcro. And Velcro can be pretty weak, but it can also be pretty strong. Have you seen those bounce houses where you put on a Velcro suit and you jump against the wall and you stick, right? I've never tried one, but I've seen people do it. It looks kind of fun. That Velcro can hold up your body weight because of the large surface area that you're in contact with. And how do you get off of the Velcro wall? You need some energy to pull it off, right? If you have two large Velcro sheets and you stick them together, it takes more energy to pull them apart than if you had two little Velcro dots, right? So if the forces that are holding these atoms together in the solid state are very strong, it's going to take more energy to break them apart, right? Where does more energy come from for molecules? It comes from increased temperature. So if the forces of the intermolecular forces are really strong, it's going to take a higher temperature to melt the substance. If those intermolecular forces are very weak, it will melt at a very low temperature. So we're going to talk about the different types of intermolecular forces.